Okay, if you haven't yet, try the next few examples and then come back to this video and check your work. Otherwise, if you've already done that, go ahead and continue moving forward. We're going to take a look at number one a little bit more in detail, and then the rest of it you'll just check. So number one, draw a scatter diagram for this data. Again, fairly straightforward to draw a scatter diagram. It's already given to you. For part B, I want to go ahead and work through calculating R, make sure you're okay with that using your calculator. So if you haven't yet, go into Stat and then Calc, right? Sorry, actually Stat Edit, right? So if you haven't yet, put your data in your list. L1 is your X list, L2 is your Y list. So type those in carefully, and then now you can go back to Stat Calc, and then again, it's option number 4. This option number 4, hit enter. And this will be a calculation we do not just for calculating R, but for finding the line of best fit in more detail. Notice how L1 is already there, L2 is there, and then there is no frequency list. If you had something in this frequency list, like now I do, I just want to make sure I clear that, and then calc. Right, so hit enter, and then again, this is your screen that you should see if you typed everything in correctly. So if we go ahead and take a look at our value of R, we have now calculated R, and so part A was done, part B is done now. Our value of R is to 3 sig figs 0.921. And then for part C, again, we want to describe the association. So whenever we're asked to describe the association, describe the relationship, that is referring to when you calculated R, right? So that value of R tells you everything that they're asking for in part C, the strength and direction of that relationship. So the strength, 0.921, I would say there is a strong, right? So strong, and it is positive, so strong, positive, you could say association or relationship between those two things. So in general, that means as starting salaries for bachelor degrees go up, starting salaries for PhDs also go up, right? So as X increases, Y is increasing. And in this case, X and Y, you can see, are those two things. Okay, and that comes from the direction of the association. The strength, right? The value of R tells you how strong that relationship is. Okay, so then for part D, the rest of this, part B and on, find the equation of the line of best fit. So that is actually back on this screen, right? So the line of best fit, the equation, comes from those other two things that we didn't, well, two of the other things we didn't really use, A and B. Notice they give you y equals ax plus b. That is the same thing as y equals mx plus b. This is slope. This is your y-intercept. It's just they choose to use A instead of M, and B is still the same. So when I write my line of best fit, just make sure you're plugging A into the A value, B into the B value. So when I do that, here are those two numbers again. When I write my actual equation, I'm going to use the rounded to 3 sig figs values. So I do lose a little bit of accuracy, but there are my two values, or my A and B value plugged into that little equation, and this is the equation of the line of best fit. It's not an estimate anymore. That is a very precise line of best fit for this data set. Okay. So for part E, starting salary for an economist with a bachelor degree is $40,000. Predict the starting salary for an economist with a PhD. So this is asking you to use your line of best fit now. All right, so part E is using this line of best fit and plugging something in. So plugging in 40,000, that is for the bachelor, that is an X value. So you're going to plug that in for the X and evaluate, and you get Y equals 59,300. So the connection, right? So you were given a bachelor degree salary and you were being asked to predict what the PhD salary would be for that same person, that starting salary. And then we were being asked to comment on the reliability. So let's think about that. 40,000. Is 40,000 within our two poles? Well, 40,000 is right here. And yes, that is between the upper and lower pole. So that would be an interpolation. And since it's an interpolation, that is often more accurate, but it still depends on how linear our data is. And as we saw earlier, that the value of R was 0.921, that is a fairly strong relationship. So the strength, right? So since R is fairly strong and it is an interpolation, then that estimate is fairly reliable. The next example, I'm going to move through kind of quick. So number 2A, draw a scatter diagram. It's already given to you. Part B, calculate R. There's your value of R, negative 0.219. The relationship. So there is a weak negative correlation between the temperature and time. And is it reasonable to find a line of best fit? So this is just asking you to stop and think, when is it appropriate to find a line of best fit? In this case, it's not appropriate. There's almost no correlation. So when there's almost no correlation, there's no reason to make a line of best fit because it would be worthless to try to use to make any estimations. Number 5, scatter diagram, calculate R. There's your value of R. It's negative, again, but 0.927. So the correlation between the two, there is a strong negative linear correlation between time exercising and time watching television. Find the equation of least squares, right? This is just another way of saying line of best fit. So line of best fit, so 3 sig figs, there you go. Give an interpretation of the gradient of the y-intercept and the y-intercept. So the gradient, remember the gradient, slope, right? Slope is negative 2.13, the y-intercept is 22.1. For every hour that the children spend exercising, they watch approximately 213 hours less television. And so for a child that does not exercise at all, we'd expect them to watch 22.1 hours of television. Okay. The last thing for part F, another child exercises for 5 hours each week. Estimate how long he spends watching television each week. So we could use the graph, but we also have the equation. So for part F, you just need to carefully plug in. So if they exercise for 5 hours, that is the X value. So that would be taking and plugging in. And evaluate that. So whatever you get from that, I don't have that answer in my PowerPoint apparently. So just plug it in, carefully evaluate, and you would get your final estimation. Okay. And that would be an interpolation, so that would be reasonably accurate due to our value of R also being fairly strong. Right? It is negative, but it's pretty strong. Last thing real quick in your Unit 4 apps, problem number 5. Number 5, part B. Just calculate the correlation coefficient. Don't worry about this notation that it gives you in B part 1. Just scribble that out. Use your calculator and calculate R and just state what that value is.